Nesting includes. Includes can be nested. What does that mean? That means one include file can also include one or more include files. Each file can then include more files. While this is possible to do and the compiler will compile just fine, it's generally not recommended. Unless you really have to, I strongly advise you not to do this. So now, how do we avoid nesting include files? One solution would be using forward declaration. There are other solutions, but in general, just try your best to avoid nesting include files. Now let's talk about the double inclusion problem. To begin with, what is a double inclusion problem? Including a header file in the same source file more than once will generate compilation errors. And this can happen as a side effect also of doing nested includes. And you will get the multiple definition of blah errors in your code. So how do we solve this problem? The first solution is by using conditional inclusion, using the if and def file name trick. This is one solution, which is usually cross-platform. It's not compiler specific. It can work for any C++ compiler. And here's an example. You can say if not defined this ID, you put everything inside the header file inside these two conditional directives. Solution number two, by using pragma once. This means that the file can only be opened or included once by the compiler. This is probably an easier way, but it's not standard. Anyways, it's been widely used, so you can find a lot of compilers implementing this. If you want to go back and forth between different compilers, maybe the first solution is better for you. Either one should work and solve this problem. Okay, so let's look into that inside Visual Studio and see how we can reproduce the problem and try to solve it. Okay, here I am in Visual Studio. Let's create a new project. Click on File, New Project. From the New Project window, make sure you have Visual C++ and Win32 selected. Then select from this list Win32 console application, and let's give this name multiple includes. Click OK. On this page, click Next, and on this page, make sure you have empty project selected and click Finish. Right click on Source Files, Add New Item to add our main.c. Click Add. Okay, in today's lecture, we're going to talk about multiple inclusion problem and how to avoid it. In order to show you this problem, we're going to have to create a header file and add some code into that header file so that we can see the problem. So let's right click on header files here, add new item. Make sure you select header file and let's call this myheader.h. Click add. As you can see, Visual Studio by default has included for me pragma once, and this is the solution number 2 that we talked about. Let's just assume we don't have this in here. Let's assume we have a function called integer sum, integer x, integer y, and then return x plus y. Just a simple function in our header file. Okay, now if we compile, nothing is going to happen because the file is not included. It's not even going to be used in my project. We want to actually include the file here, include myheader.h. I'm using the quotation mark because it's a local file. And now let's go ahead and use it. Say integer total equals sum and 20. Let's see if we can compile this. Ctrl+Shift+B on the keyboard. Okay, so this is compiling just fine. Now, how do we see this problem? Let's include this multiple times here. Let's assume we have it like this. Ctrl+Shift+B. Okay, now I'm getting some errors. Let's look at the errors here. Error function integer sum already has a body though. So this is one indication of multiple inclusion problem. You get this problem because you have the function defined multiple times. The compiler says, I already have seen this function implemented. Why is it implemented twice? So let's go back to our header file here. Right click on the header file and click on Open Document. Now it's open. So now the first solution to avoid multiple inclusion problems is by using the if and def. And typically developers will do something like this. For each file they have, like in this case, this is my file, my header.h. they would say if indef underscore my header h, the first thing you do is you say define my header h, and then you start adding your code here, and at the very end you have to say endif. So now let's save this file. Ctrl S to save, or you can click on the save icon. Let's go back to main and try to compile it. Ctrl Shift B. So now, as you can see, I have successfully compiled my program. Even though I have this include multiple times, it's not going to impact the compilation, because the first solution we used here is by including if and if to this. When the compiler compiles this the first time, it says if not defined my header. The preprocessor first time looks at this, it says not defined. This will be true the first time. It will actually include everything here with the first include. But as it does that, it also defines this. So the second time this gets compiled or preprocessor comes here, it will look again at the code and say if not defined my header, but previously you can see we defined it. That's why it will not actually include the code. This is like a no operation here. Same thing goes for this and this. Some people might run into the problem where they actually forget this line here. So if we comment this out, come back here and compile, Ctrl Shift B on the keyboard, then they will still get the same problem here. As you can see, I'm getting the same problem again because I have not defined this. So this will always be undefined. So what makes it defined is this line here. It's better to put this as the first line. Some people might do it at the very end. It's better to do it at the very beginning as a convention. So this is solution number one. Okay, so now let's go back to solution number two. Instead of doing the whole thing in here, most compilers now have this pragma once, which means that this file will only be processed once. So now let's go back here after we save everything and compile again, Ctrl Shift B. As you can see, it's successfully also compiling. That means pragma once has the same effect as the first solution. Like I said, this is not standard, but it's widely used by a lot of compiler vendors. If you want your code to be compiled by different compilers, then you probably want to use this technique instead of the other technique. Alright, so that's it for the multiple inclusion problem and how to avoid it. Finally, one small thing I want to say is that I don't recommend that you put your code in header files like this. This is just for example purposes. Typically, you would want to break your code into its own source file and just put the prototype here. And the function itself should be in its own .c or .cpp file. I just wanted to show you an example of the multiple inclusion problem here. That's why I'm implementing the function in place here, but never do this in real code. You should actually put this in its own cpp file or C file and put the forward declaration only in the header file. Forward declaration in C++. In this lecture, we will talk about forward declaration. What does it mean? When do you need it? And how you can use it. So let's jump right into Visual Studio to see how we can do that. Okay, so here I am on Visual Studio. Let's go ahead and create a new project. Click on File, New, then click on Project. Make sure you have Visual C++ 132 selected. Select 132 console application, and let's call this one Forward Declaration. Click OK. On this page, we'll click Next. On this page, make sure you have Empty Project selected, then hit Finish. Let's go ahead and create our main.c. Right-click on Source Files, Add New Item. Let's call this main.c. Click Add. In this lecture, we're going to learn about forward declaration in C++. Let's start by an example that shows us why we need forward declaration. So let's assume we have a function called max that takes two numbers, a and b, and it will print out the maximum. In fact, it doesn't have to return it. And just print out the maximum. If a is greater than b, we're going to call a function here called print max and give it a. Else, we are going to say print max and this time give it b. Alright, so this function doesn't exist yet. So if we compile Ctrl Shift B on the keyboard, As you can see here, warning, print max is undefined, assuming an external function returning integer. And then the linker would fail, saying we cannot find this print max, so I cannot generate the executable for you. All right, so this assumes there has to be a function called print max that we are calling here. So now let's go ahead and define this function. Void print max takes an integer n and prints it out. Say print f, the max is %d, and we give it the n. So now we have defined this missing function. However, does this actually solve the problem? Let's see. Ctrl+Shift+B to compile. And as you can see down here, we're still getting an error. This error is slightly different, but it still doesn't understand the print max. So what is happening here is that when it compiles this function, it would assume that it knows about print max before it actually can compile this function. So one way to solve it is to actually take this function from here. I just cut the function with Ctrl+X, and then I'm going to paste it over here on top. Ctrl+V to paste it. Now it's in the order that the compiler can understand. It will look at this first, compile it, understand it, and then when it looks at its reference here, it will not complain. So let's see, Ctrl+Shift+B again. As you can see, I have successful compilation. This means that every time I need to call a function, the compiler needs to know how this function is implemented. As you write more and more code, this is not something easy to do. You're going to run into issues where you can't always put the functions or the code in the order that the compiler expects. This is where forward declaration comes in handy. Let's assume that you want to put this in its own library. So that means it's not going to be here. It's going to be in a separate library. Well, in that case, how would we tell the compiler that, hey, don't worry about this. This is defined somewhere else. And that's where we use the forward declaration. First of all, let's assume I can put it here. Even though I can put this in a totally separate file, I'm just going to put it here right now. And come here and tell the compiler I'm going to forward declare my function. And the way to do it is to take the same prototype. This is called the function prototype. Copy that and paste it here. And this is what we mean by forward declaration. So what forward declaration means is that you're telling the compiler, hey compiler, I'm declaring a function here. This function is called print max. It's going to return a void and take an integer number n. So the compiler will understand that by looking at this declaration that, okay, I expect there will be a function that's declared like this to be defined somewhere. And it just happens to be defined in the same file here later on. And this is really useful so that we can call the function before we even look at its implementation. So now let's compile this, Ctrl+Shift+B. And now as you can see, it's successfully compiling, no warnings, no errors. So this is the function forward declaration. Not only it's valid for functions, it can also be used for variables. Okay, finally, we can now take this away from here and put it in its own source file. In fact, let's do that. Right click on source files and say add new item. I'm going to add a new item here. Let's call it printmax.c. Click add. And this is my printmax.c. I'm going to take this function, Ctrl+X, to cut the function from here, from main.c, and put it inside printmax over here. And now let's hit save all to make sure everything is saved. And let's compile this, Ctrl+Shift+B. Now we're getting a different error here. Same problem, but with the printf function. Now, if we look at our printmax, you can see it's actually using printf. And as the compiler is compiling this unit, so this .c file is its own unit now. It's being compiled separately. As it compiles this, it says, oh, printf, I don't even understand what printf is. So that's why we get this error here, warning. To fix this, we also have to include standard IO in here. So Ctrl+Shift+B. Now we have successfully compiled the program. So the code that is generated is the same. The only difference is that now our code is split into two files, printmax and main.c. This is how we split the code into multiple files. As you can see here on the right, there's main.c and there's printmax.c that are now part of my project. In fact, this can also go into its own header file. Right click on header files, add, and say new item. And in this case, we're going to click on header file, and let's call it printmax.h, add. And now, as you can see here, I have a new header file added to my solution and my project. It's called printmax.h. Okay, so I'm gonna switch to main.c again, cut this from here, put it inside printmax.h, and save it. Since we took it out from here, now if we try to compile, we're gonna get an error because we need to include that header file. So we have to say hash include. And as you can see, I'm using quotation marks here because the file is local to me. And the minute I do that, the Visual Studio is really smart enough to tell you that, hey, from within the same directory, there's this file and there's this other subfolder. So I'm gonna use my printmax.h here. And now I have included that file. So if I say Ctrl+Shift+B, now you can see it's compiling just fine. What did we do today? We learned about forward declaration and how to split the function into its own file, as in this example, and how to have its forward declaration into its own header file, and also how this function here is being included with the quotation marks, and now we can use it in here. Last thing we might talk about is if you want to open this, you can right click on it and say open document. It will go to its file and open it. Another way you can do it is you can actually click on the keyboard Ctrl+Shift+G for go to, and it will open the file. So if you're inside this here, you can hit on your keyboard again Ctrl+Shift+G, and that will open it. Same thing actually for standard I/O. If we want to open standard I/O, we can say Ctrl+Shift+G. See, now it's opened that file for me. So that's it for this lecture. Working with multiple source files in C and C++. In this lecture, we're going to look at how we can actually simplify our life by breaking large pieces of code into multiple files. As you start adding code to your existing projects and existing file, you would realize quickly that a single file is really not easy to maintain, not easy to handle. Things will go out of hand quickly. So in this lecture, I want to show you how you can break your code into separate files of their own so that you can maintain them much easier, and you can categorize your code into different files based on their usage and based on what they represent. For example, mathematical functions can go together in a single file, etc. So this is just an example of how you can do it. So what are the advantages of this? The first advantage is that a smaller number of functions will be in a single file, which is easy to maintain and easy to read quickly and update. Also, it's easier to study and understand the content of the file, whether it's you or another developer who's working on it. And also, you can just simply take that file alone and reuse it and turn it into maybe a library in the future. Okay, let's switch to Visual Studio to see an example of how we can go from a single file into multiple source files, and also how we can create our own header files that go along with the source files. So if you have a math library, you can say, I have my math.h and my math.c. If you have a string library, you can call it my string.h, my string.c. All right, so here I am on Visual Studio. Let's go ahead and create a new project. Click on File, New Project. And let's call this one Multi-File Example. Click OK. On this page, click Next. And now let's make sure we have empty project selected and then click Finish. All right, I'm gonna add our first source file, which includes the main function. So right click on Source Files, Add New Item. Now we're gonna include main.c, which has our main function. Click Add. Okay, so today we want to learn how to work with multiple source files in C and C++. Let's assume we have created this file. Just to save you time, I copied functions we have created together in previous lectures into this single file just to show you the problem we want to solve here. Let's assume we have a function called integer sum that takes an array and then returns back to the caller the total sum of all the elements in the array. So at the top we have sum, then after that let's say we created a maximum function which finds the maximum element inside the array, returns that to the caller. And then later on, let's assume we created a factorial function that calculates the factorial of a given number. Up to this point, these are all like mathematical functions. And now we started manipulating strings And now we have this remove spaces function, which you give it a string and it strips out all the spaces inside it. And then after that, we needed a function, for example, that's going to count the number of words inside a string. Given a string and a word, it counts how many times this word was found inside a string. And lastly, we have a reverse string function. Give it a string, it reverses that string and send it back to the caller. As you can see here, if we keep adding more and more stuff, quickly our file becomes not easy to maintain and not easy to navigate around. Let's see how we can simplify our life by moving this code here into its own math file. So let's do this. Let's add a new file that is going to contain all the mathematical functions. Right click on source files again and add new item. Now let's call this one mymath.c. Click add. And now as you can see, there's a new file called mymath.c. We can write a comment here. mymath.c contains all my math related functions. Okay, so let's go back to the main.c. And I'm gonna cut this code from here. So with the keyboard, I can hit the shift key down and then use the down arrow so that I can highlight the stuff I want to cut as I'm scrolling down. Up to this point here, I'm gonna cut all this. You can right click with the mouse and say cut, or as you can see with the keyboard, you can say Ctrl X. So let's click on this. Now, as you can see, this is gone from here. Let's go to the mymath.c and paste the code in here. You can do paste from the menu or Ctrl V on the keyboard. Okay, so now the code is now pasted into this file. Let's go ahead and save it. Ctrl S. Now we saved it. And let's also save main.c. We can compile this file alone to make sure it doesn't produce any errors. To compile this, one way is you can right click on the file here and there should be a compile option or Ctrl F7 on the keyboard. So compile. Looks like this is compiling just fine. Alright, so this is the first step. We actually reduced the main.c quite a bit by removing the mathematical functions out. Let's do the same thing for the string functions. How do we do that? We need to add another file to the source file. So right click on source files, add new item. Let's call it mystring.c. Click add. Now we have another file called mystring.c. mystring.c contains all string related functions. You could probably give it a better name, mystring library, mystring sources, mystring functions. I'm just giving this as an example. Okay, so now in our project, we have three files, main.c, mymath.c, and mystring.c. So let's move all the string functions into this file from main.c. Same thing, click on main. With the mouse also, you can highlight everything here by clicking on the mouse and then scrolling down all the way to the end. We leave the main inside this file because main.c should only contain main function. Right click on the selection and then say cut. Go back to mystring.c and then right click again and paste it. Okay, let's save this. Ctrl S on the keyboard. As you can see now, I'm getting an error here. I think if we try to compile this, let's try to compile it. Right click on mystring.c, compile. We should be getting an error or a lot of errors here. As you can see, we're getting a lot of errors down here. And the reason is that null is not defined. We have to actually include at the minimum string.h, copy it and put it inside mystring.c. So let's put it here at the top. So now you can see null, the red squiggly line is gone. So now let's try to compile again. Right click, compile. Okay, it's compiling fine. Cool, so we have just moved all the stuff that we had in one big file into separate files, which makes the code much easier to read and compile and maintain. So now we can even share this mymath.c or mystring.c with other projects without having to put program or project specific logic into them. These become like generic functions. Now the next question is, let's say we want to call this function inside main.c. If I wanted to call it here, how do I do that? Let's say I have an integer array equals 1, 2, 3, 4, 5, 6. And I want to pass it into here, give it a. I know for now it's 6 elements. Integer total equals summation of all the elements inside the array. If we try to compile this, we're going to get an error. In this case, we're getting just a warning saying that sum is an undefined function assuming extern returning integer. So in this case, it's not really a big issue. A better example might be my string.c. Let's try to call reverse string inside main.c. Char str equals, let's say C++ is really cool. And we assume that we want to reverse the string like this. So if we compile it, we're going to also see the same warning here. But if I say char pointer p equals this, as you can see, it actually doesn't know what exactly this function is going to look like. This is where we need to tell the compiler how these functions look like exactly. So if we had this function prototype in here, and we've covered prototypes in a previous lecture, if we had it like this, then the warnings will go away. If I compile again, you can see the warnings are gone. In fact, instead of doing it this way, we should just move all the function prototypes, their declarations, into their own header files. So just like we added .c files, we should add also .header files. So right click on header files here and add a new item. Let's add the first one. Let's call it mymath.h. Like add. So now we have mymath.h. What I'm going to do is I'm going to go to mymath.c, find all the functions we have here, copy their prototype, Ctrl+C on the keyboard, go to mymath.h, and put the prototype in here. Function prototypes. Note that to make it a function prototype, you just take the function header followed by a semicolon. So this is like forward declaration. This is announcing to the compiler we're going to define these functions. So this is one. Let's find the second one. The integer max is the second one. And I'm going to switch between mymath.c, mymath.h. Copy the second one here, semicolon at the end. Go back to mymath.c now and scroll down. Find the last function here. Copy this into math.h. And then semicolon at the end. If you remember from the header files, a better way to do this is to include at the beginning #pragma once, or use the if and if declaration to define so that we avoid multiple inclusion problem. Okay, so now I'm going to save this. Ctrl+S on the keyboard to save it, or you can just simply click these icons here, save icons. So this is saved. Let's do the same thing for mystring.c. We're going to give it a header file. So right click on header files, add new item. Let's call it mystring.h. Add. Again, pragma once to avoid multiple inclusion problems. And then we're going to go to the file and find every function, copy the header of the function into the .h file. And don't forget to add a semicolon at the end. So that's one. This is the second one. Copy that into mystring.h. Semicolon at the end. I think there's one more at the very bottom here. It's called reverse string. Put this here as well. Semicolon, and we're done. Make sure everything is saved. What we did here is we actually created two header files and two C files. Each source file and each header file should be matching each other. If you want to look at where we created these files, you can simply come here and right click, say open containing folder. And as you can see here, this is where I have my main.c, my math.h. So all of these source files actually live together in the same folder. All right, now let's go back to main.c. We don't need this here. And get rid of this. Let's compile. We're still getting the same warnings. To avoid these warnings and to make the compiler understand where these functions are defined, we bring in the header files in here. So the question is that we use angle brackets or quotation marks. You remember from previous lectures, we use quotation marks because, as you can see here, it's going to start with the local directory, the same folder as the main.c. And even Visual Studio is so smart that it actually will browse the folder for you and show you the content of that folder, which makes life easier because we can just simply select from this list, hit enter. That's my math.h. I'm going to do the same here for my string.h. So now I bring all the definitions into the compilation unit of main.c. Okay, so now if I compile here, I should not get any errors or warnings. Ctrl+Shift+B to compile. As you can see, we successfully compiled with 0 warnings. So basically in this lecture, we learned how to break our code into separate source and header files, why we need in the header files to define pragma once, and why we should put the forward declarations, all the prototypes of the functions in that file in here, so that when we start referencing them in any file that references them, you should include the header file. And we do the same thing, for example, with the C runtime. When you say printf function, that's when you actually include standard IOH that defines this function. Without this header file, you will get some compilation warnings or errors. Same thing applies to our own code. In this case, we just simply use the sum function and the reverse string function just to show you how we can break the code into multiple files. Okay, so that's it for this lecture. In the next lecture, we'll explore how we actually can even take this a step further and turn these into their own separate libraries. Right now, we always include the source code with the project, but there's a way you can actually simply include the header file without the sources and hide the implementation from whoever is going to use your code by building a library, a static library in C and C++. So see you in the next lecture.